The universe was born 13.8 billion years ago in a single moment of unimaginable heat and energy. Everything you have ever seen, touched, or thought about exists inside this one vast and ancient cosmic structure. But nothing lasts forever. Not stars, not galaxies, not even the fabric of space itself. The universe is dying slowly and silently, and scientists have mapped out exactly how that death will unfold. The era we live in, the Stelliferous Age. Right now, the universe is in its golden age, a period astronomers call the Stelliferous Era. This is the age of stars, where hydrogen is still abundant enough to fuel the birth of new suns across the cosmos. Our own sun is roughly halfway through its life, with about 5 billion years of fuel still remaining. During this era, galaxies shine brilliantly, nebulae collapse into new stars, and planets form around them regularly. But this golden age is already beginning to slow down, and new star formation is declining across the universe. The rate of star birth today is only a tiny fraction of what it was 10 billion years ago at its peak. The universe is not getting more alive. It is gradually running out of the raw material needed to make new suns. This era will continue for roughly 100 trillion years, but eventually the last star will be born. The death of our sun, 5 billion years from now. Before we talk about the universe's end, we need to talk about the death of our own star first. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core and begin to expand. It will swell into a red giant, growing so large that it will swallow Mercury, Venus, and possibly Earth itself. The oceans will boil away, the atmosphere will be stripped off, and the surface of Earth will be scorched bare. After the red giant phase, the sun will shed its outer layers into a glowing shell of gas called a planetary nebula. What remains at the center will be a white dwarf, a dense, slowly cooling ember the size of Earth. That white dwarf will shine faintly for billions of years before fading into a cold, dark, invisible black dwarf. The death of our sun is not a dramatic explosion. It is a long, quiet dimming that ends in total darkness. The degenerate era. When stars go dark, after 100 trillion years, the last stars in the universe will finally burn out one by one. The universe will enter what scientists call the degenerate era, a cold and almost completely dark period of existence. The only objects still shining will be white dwarfs, slowly releasing the last of their stored heat into the void. Brown dwarfs, failed stars that never ignited, will drift silently through empty space with nothing around them. Neutron stars, the crushed remnants of massive suns, will spin slowly in the darkness like forgotten lighthouses. There will be no new stars forming anywhere, no light from galaxies, no warmth reaching any surviving planet. The universe will be a vast, cold cemetery of dead stars drifting apart in an ever-expanding darkness. This era will last from 100 trillion years to somewhere around 10 to the 37th power years. The black hole era. Monsters inherit the dark. As the degenerate era ends, even white dwarfs and neutron stars will eventually decay and disappear. A process called proton decay, if it exists as physicists predict, will slowly dissolve all ordinary matter into energy. Atoms themselves will come apart, and everything made of matter, every rock, every world, will simply cease to exist. What will remain after all matter is gone are the universe's most extreme objects, black holes. Black holes do not decay the way stars do. They grow by consuming anything that comes too close to them. The largest black holes in the universe, called supermassive black holes, contain the mass of billions of suns. During the black hole era, these giants will drift through an empty universe, occasionally merging with one another. Nothing will be left to feed them, and space will be almost perfectly empty in every direction for incomprehensible distances. This era will stretch from 10 to the 40th power years to 10 to the 100th power years into the future. Numbers this large have no real comparison in human experience. They are beyond imagination, beyond language. Hawking radiation, the slow evaporation of black holes. Even black holes, the last survivors of the universe, are not truly immortal. Stephen Hawking discovered theoretically that black holes slowly lose mass through a process called Hawking radiation. At the event horizon of a black hole, pairs of particles constantly appear and one of them escapes into space. Over an almost incomprehensible span of time, this process causes the black hole to slowly shrink and lose energy. A stellar mass black hole might take 10 to the 67th power years to evaporate completely through this process. A supermassive black hole at the center of a galaxy would take far, far longer than that to disappear. But eventually, every single black hole in the universe will shrink to nothing and release one final burst of energy. That last flash of radiation from the last black hole will be the final event in the history of the universe. After that moment, there will be nothing left. No matter, no energy concentrated anywhere, no structure of any kind. The heat death, the true end. The final state of the universe has a name that sounds almost peaceful. It is called the heat death. Heat death does not mean the universe becomes hot, it means the opposite of that entirely. It means that all energy in the universe has spread out so perfectly and evenly that nothing can ever happen again. In thermodynamics, this state is called maximum entropy, a condition of absolute equilibrium and total stillness. No temperature differences will exist anywhere, which means no heat can flow and no work can be done. Chemical reactions cannot occur, physical processes cannot begin, and no form of life could ever exist in this state. The universe will not explode, collapse, or shatter. It will simply stop forever, in perfect and absolute silence. Every photon of light will stretch to infinite wavelengths as space continues expanding, becoming effectively meaningless. The universe will not end with a bang or a scream. It will end with something far more haunting than either. What this means for us. On a cosmic scale, everything humanity has ever built, created, or loved exists in the first fraction of a second of this story. All of human history, from the first fire to the last city, fits inside an impossibly thin slice of cosmic time. The stars that fill our night sky tonight are temporary visitors, burning brightly before they too disappear. Understanding the death of the universe does not make life meaningless. It makes every moment of light more precious. We exist in the rarest and most beautiful era of the universe's entire existence, surrounded by stars and warmth and time. The universe is dying, yes, but right now, in this moment, it is still magnificently and breathtakingly alive.